Okay, here's the question. Here's the question. The angle theta is located in quadrant 4, and cosine of theta is equal to 9 over 19. We have to figure out the value of sine of theta. And we're going to use the Pythagorean identity to do that. That's cos squared theta plus sine squared theta equals 1. So the first thing that we're going to do is substitute in 9 over 19 for cosine of theta in our identity here. So that becomes 9 over 19. And in the formula, remember, we are squaring it, so that's going to be squared. Plus, and then we finish this off at sine squared of theta, which will equal 1. So now if we square 9, we get 81. And then if we square 19, that is 361. Then we have plus sine squared of theta equals 1. And we're going to solve this for sine squared of theta. So what we're going to do is subtract both sides by 81 over 361. That goes away. And then we're going to have 1 minus 81 over 361. And that's going to leave us with sine squared of theta equals 1 minus 81 over 361. So now if we're going to solve, let's simplify this part, all right, before we do anything with sine squared of theta. So let's simplify that. We're going to do sine squared of theta again, okay, equals. Now, we want to subtract these, or we want to subtract 81 over 361 from 1. And to do that, we need a common denominator. So if we rewrite 1 right here is 361 over 361, that's the same thing as 1, right? And then we're going to continue and do minus 81 over 361. And that's what you can do with all these problems if you want to do this by hand. Or you could use your Inspire calculator, and that would do this subtraction process a lot quicker. But anyways, we are going to be left with sine squared of theta equals 361 minus 81 is going to be, I think it's 280 over 361. Okay, so now we're left with this. The next step is going to be to get rid of this squaring. So we square root the left side and the right side, and then we are left with just sine, because that 2 goes away. We're left with sine of theta, which will equal the square root of 280 over the square root of 361. And if you take the square root of 361, that's actually 19. So we're going to put that down here like that. Okay, and now you could simplify a little bit. If we rewrite sine of theta equals the perfect square that is a factor of 280 is going to be 4. So if you separate the square root of 280 into the square root of 4 times, I believe that is 70, you could rewrite it like that. Okay, and then the square root of 4 is 2. And then we've got the square root of 70. And that's going to be all over 19. And that's what sine of theta is equal to right there. And that's what we're looking for, right? The question says all the way up here, what is sine of theta equal to? And we said that that was going to be 2 times the square root of 70 over 19. That's what sine of theta is. But there's one more thing that you have to do. Okay, the problem said up here that the angle theta is located in the 4th quadrant. So let me do a coordinate system here. This is the 1st quadrant, 2nd quadrant, 3rd, and 4th. And theta is going to be located in this one. And right now we're saying that sine of theta is equal to, I think it was 2 times the square root of 70 over 19, right? Well, we have to do this last step to see if it's going to be positive or if it's going to be minus. Okay, that's the last step you have to do. Okay, check to see if it's going to be positive or minus. So, or positive or negative, I'm sorry. So how do you know that, right? Well, don't forget, cosine of theta, comma, sine of theta is what matches up with xy, okay? And if we're working in the fourth quadrant right here, and it's sine, right? This is what we're working with, sine. That's the y value. And we know that any y value down here in this coordinate, or in this quadrant, that's going to be a negative. All right, so I'm going to make that negative. And if you're thinking like, wait, what? Well, imagine if you had to graph the point 3 comma negative 2, right? That's going to be 1, 2, 3, and then down 2. So it's going to be somewhere down here, right? And that y value is negative, okay? Any point that you graph down here, the y value is always going to be negative because it's below the x-axis, okay? It's below that, so they're going to be negative. So that's why you have to change this to be negative, okay? I'm going to put this up here too. Both values of your coordinate are going to be positive in the first quadrant. X is negative here, y is positive there. In this quadrant, both coordinates are going to be negative, the x and the y, and then down here the x is positive and the y is negative. So in this quadrant right here, you could always say that no matter if you've got sine or cosine, the answer is always going to be negative if you are working in the third quadrant.